So when you are taking samples, okay, uh, quite possible that your sample may not be perfect. Okay. Uh, Quite possible that your sample may not be perfect. So because your sample is not perfect, that means the error that you that the difference that you are getting because of the population mean, because of the population mean and the sample mean is called as, so the error or the difference between the population mean and the difference between the population mean and the sample mean, it's called sampling error. Is it okay?
Yes, sir. So is the formula same as standard error of sample mean?
uh, no, standard error is different now. Okay. Now why this is happening? Because you have taken wrong samples, or you have, because say for example you have not taken sample correctly, you have taken judgmental sampling, you have done convenience sampling, because of which this sample error and this population error, sample error and population errors are I mean sample mean and population means are different. So we call that as what? Sampling error. Because of the sample, that error is coming up. Okay.
Okay.
Standard error means what? Standard error is in, so standard error means when I'm creating, I'm checking various samples. Sample means, okay, various. This is first sample, second sample means third sample, fourth. So various samples I have tried. Okay. When I tried various samples, the first sample gave me some, 10, 12, 15, 14, 11, 18, 17. Now, what is the standard deviation? So standard error is the standard deviation of the sampling mean. That is directly given, standard error. Ah, standard error of the sample mean is the standard deviation of the distribution of sample means. That means these are all the means. These all are the means, sample means. Okay. Standard deviation of this sample means. Standard deviation of the sample means what? I will put this number, let's say in the calci, or I'll keep it like this: 10, 12, 15, 14, 18. This is 14, 16. Let's say this is 16, 18, 17. And I will take the standard deviation of this number. When I will take the standard deviation of this number, that is called as standard error, because all these are what? All these observations are sample means, na?
Yes,
All
yeah.
these observations are sample means. So otherwise, normally it is what? Standard deviation of the observation. But because all these are sample means, so standard deviation of the sample mean is called as standard error.
Okay.
Standard deviation of the sample means, or the distribution of sample mean is a more appropriate word.
Okay.
Generally, you can say standard deviation of the sample means.
Okay. Understood. And so confidence interval will be the complement of level of significance, right?
Yes,
So the
yes, yeah,
probability of it happening.
yes, yeah.
Okay.
Okay, so till where did we finish? Um, yeah, I'm supposed to tell you all that theory na, in between that I have not yet done. So today I'll just summarize again. So today all this little difficult part all will be done. Did you get time to go through this
Yes,
hypothesis?
sir.
Went through? Okay. Okay. So first one, this is we did the first one. So this is uh, yeah. So when you want to check sample mean, sample mean, okay, mean. Focus on the word mean. Sample mean with the population mean. Then we will go for z test. X minus mu divided by standard error, or else we will go for t test. Again x minus mu divided by standard error. Okay. Now this should be if population, that condition, if population variance is known. If population variance is known.
Okay.
Population variance is known. This is if population variance is unknown. This is I'm referring to that table. You remember that graph?
Yes.
That graph. Hypothesis, population variance unknown, known, normal distribution, non-normal distribution. That one. If population variance unknown. Okay, I'll write that as well so that it becomes a complete, video. So here, hypothesis testing. Um, Population variance known. Population variance unknown. Population variance known में है, population variance known as normal distribution and non-normal distribution. If it is normal distribution, go for z-test. If it is non-normal, if it is greater than or equal to 30, go for z-test. Otherwise, if it is lower than 30, go for t-test. So population variance, normal distribution, and non-normal distribution. So normal distribution, go for t-test. And non-normal distribution, n is greater than or equal to 30 and n is lower than 30. T-test. And here it is no test. Sorry, no, lower than 30 is no test, na? No test. Okay. Yeah, so this part is okay. Next one, see this now. This is what we did in this sum. And if the n is too large, like here 250, so it doesn't matter whether the population variance is known, unknown, doesn't matter whether you're taking z test, t test, all will lead to the same answer. So that's why anything you can use at that time. So that's why here, see, population variance is actually unknown in this case. So now I'm filling the gaps in the sum. Okay, so population variance is unknown, but still, because it is 250, they have taken um, they took z test, right? See, z distribution is acceptable. See this here,
Yes.
t distribution and z. You can read this part now.
Yes, sir.
Okay. Then next sum, difference between means. This I did not tell you, but we did this sum. Difference between mean equal variances. Okay, and in this sum, all we saw was that it is minus 5.474 t statistics, and so we had the critical value plus and minus 2, so it was falling on the extreme left hand side, and then we rejected the null hypothesis. Now something more. Okay, here the important points are, this is what will be tested, this point. Now what is this difference between means independent sample? That means different between means independent sample, and another next one is different, next one is dependent samples also will come. Difference between means independent samples, that means I want to check whether the mean return of ICICI is equal to the mean return of TCS. Both are different, right? One is into bank, another one is into IT. So I want to check whether their
Yes.
mean return is also different or not, same or different. You understood the topic? Difference between
Yes.
means. So difference, right? Difference. Difference between means. Difference between means independent samples. See, most likely this kind of question they will ask again theoretically only, so you cannot underestimate the theory in it. Okay. In
Yes.
fact, more than some sums are actually very easy. Just you have to just see that t statistics and then you can quickly conclude. But it's the theory that becomes difficult, and so they will ask theory only. Independent samples. Okay. So here the condition is a pooled variance. This is a very important point. Samples are independent, that we have already written here. Samples are independent, taken from two different populations that are normally not distributed. That are normally distributed. Sorry, that are normally distributed. Two different population means ICICI and TCS. Both are different populations, right? Now pooled.
Yeah.
So in this case, pooled variance is used with the test for testing the hypothesis that the means of two normally distributed populations are equal. Okay, when the variances of the populations are unknown but assumed to be equal. Okay, pooled variance is used with the t-test for testing the hypothesis that the mean of two normally distributed populations are equal. Yeah. So here, first we are assuming that their means are equal. Null is equal, right? No change. Then another one is not equal. They both are different. Now condition here is what? Population variances of the populations are unknown but assumed to be equal. Assumption. This assumption is very important. Okay. Variances of the population are Variances of the populations are unknown, but assumed to be equal. This line is very important, okay? Variance of the populations are unknown but assumed to be equal. So in this case, the formula is, now see, normally we write t-test like this. This is maximum case we use, okay? This format, see this one. X minus mu divided by standard error. That x minus mu only, now you see how it changes. X1 bar minus, this is x bar minus mu. I can write like this, x bars. This is a mean. Okay. So now uh, x bar minus x1 bar minus x2 bar minus mu1 minus mu2 divided by, so this was standard error, so that will be root of uh, pooled variance divided by n1 plus p stands for pooled variance divided by n2. So what does this pooled variance mean? So pooled variance is equal to n1 minus 1 into s1. S1 is in variance, okay? First one variance plus n2 minus 2 s2 square. n1 plus n2 minus 2. Okay, so this is if at all they ask you also this question again, there is one question in the website where they have asked only the formula. Formula means formula was the options ABC and you have to select the right formula. That way they asked, but you can still remember it. You never know, if at all it comes also, it will be very easy, just direct plug-in number only. Okay, here the condition is variances are unknown, but we are assuming it to be equal because it is equal. So we have pooled them together. So we have clubbed them all together. Pooled variance. So S square means standard deviation square, which is pooled variance. Is it okay? Now this
Yes.
number only actually comes as minus 5.474. Okay, so in this sum, I cannot practically do that. All that information is not given here. Okay, so I took the shortcut to explain it to you, but that time you wouldn't have imagined all these things. You would have simply imagined this t-test, right?
Yes.
Okay, so but actually this is the story here. Okay. Uh, yeah. So two variants are equal. Is this fine now? So this also you
Yes.
have to know. Okay. Now after this, if you want to read later on all these things, you will understand now. Okay, later on when you read, you will understand. All this highlighted part you should certainly read. And again, I'm telling you, they will ask you this question in the form of theory. Theory means what? Like variance is known or unknown, assumed to be equal or unequal. That way they will ask. Suppose if it is unequal, okay, if it is instead of equal, if I say it is unequal, it is not given in the book, but it was there in one of the website question. Then if it is, if variances of the populations are unknown and assumed to be unequal, then what will happen? Then the formula changes like this. T is equal to x1 bar minus x2 bar minus mu1 minus mu2 divided by root of variance 1 by n1, variance 2 by n2. Okay. So this is the change if it is unequal. Is it okay?
Yes, sir.
Okay. The next one. Now paired comparison. Okay. So paired comparison means of dependent sample. Okay. Paired comparisons means of dependent sample. So paired comparison means what? In this case, samples are dependent. Dependent means what? Now let's take the example of HDFC banks, HDFC Bank and ICICI Bank. Now they both will have same sources, right? Like interest rates. Based on the interest rate only, they both are moving. So these are all what dependent samples. Okay, so in such cases, see, this paired comparison is also called as means of the differences. Means of the differences. So earlier case was difference in means. Now this is means of differences. What does this mean now? Means of differences. Okay. Means of differences means okay. Means of differences. Say for example, there is x and there is y. Okay. And x is written is 10, 12, 15, then 13. Y is written is 12, 11, 17, then 10. Now differences. So differences will be what? -2, +1, -2, then 3. Okay. So here means of differences. Huh. D minus D bar the whole square. Okay. D minus D bar. Means of the differences. Acha, only the difference. Sorry, I forgot that. Only the difference. So absolute value will come. Okay. Only the differences, right? Absolute value will come. Only the differences. So positive, all positive number. Now you take D bar. D bar is equal to what? Just calculate the average of this number. 2 plus 1 plus 2 plus 3.
2.
Hmm?
2.
2. So this is D bar. Okay. So now T is equal to, so you find out its standard deviation also. You know the shortcut to get it from the Kelsey?
No, sir.
Okay. So we can get this from the Kelsey also. So I'll tell you how to use standard deviation shortcut way. So far I did not tell you because I wanted you to practice the long cut also. So but now I'll just tell you the shortcut also. So in your Kelsey, just you have to activate this data function. Okay, data. So you do second and 7.
Yes, done.
Okay. Then the value that we have taken is 2123. No? 2123. So 2, first one, enter. Okay, downward arrow. Why you leave it blank? Reason being, leave it as it is, because right now we have only one variable. Okay, we don't have the second variable, but which you will see in the next chapter. 2 variables. That time you will come to know. So this one you leave it blank and then do downward arrow and come to x2, and that x2 is what? 1. So it is 1. Enter. Do like this.
Done, sir.
And okay, enter, downward arrow, leave this one, ignore it. Downward arrow, x03 is 2 and 3. So 2, enter, and then 3. Okay. Done till here, done. Now you
Yes.
do second and 8. 8 means stats you want. Second and 8. You will
Okay.
get lin like this in your Kelsey, lin.
Yes.
Then downward arrow. Now you keep doing this downward arrow. See, x bar is 2, which we already calculated. So actually there was no need to calculate this also. Shortcut ways are there. Okay. Downward arrow.
Okay.
Can you see this one is standard deviation of x? 0.82 sample standard deviation. This is population standard deviation. Okay. If you ever get confused, like I always get confused, all I know is between this one, I know that the bigger number is sample. Okay. And the smaller number is population. This symbol is population. Okay. So we want this one, 0.82. Is it fine?
Yes.
0.82. So standard deviation is 0.82. So standard deviation 0.82. What else is required then? Standard deviation is 0.82. Standard deviation of differences is 0.82. Okay. So then 0.82, and then the mu with which you are comparing. Okay. Whatever mu is given in the question. Say for example, the mu is given as say for example, the mu is given as maybe like maybe like 9 percentage or maybe 12 percentage, let's say 12 percentage. So t is equal to stand d bar, which is 2 minus uh, let's say, what did I say, number 12 percentage, divided by, or leave percentage, say 2 is equal to 2 minus uh, 12 divided by standard deviation is 0.82. Calculate this.
$12.195 minus.
Yeah. Acha, this difference, this is like too much. I should find out, let's say the d bar is something like, see here, the difference. Now, normal difference is, let's say, something like maybe 3 percentage, something like this, 3-4 percentage. Then we have to just take this difference. Now, whatever number comes, then we can check with -2 +2.
So
Right.
this is 2.43
Hmm. Then we can say
minus.
yes. Okay, minus.
Mm.
Then we can say this is significantly different.
Yes.
2.43 is falling outside the range. That means this difference is significant. Okay, you
Okay.
understood this one. So they will not
Yes.
ask you the sums. Okay, but then again, theory, and this is called difference in means. Sorry, not difference in means. This is called means of differences. That line, people get confused with that line. Difference in means. This is one simple sum. Okay, difference in means. This is the formula. What is the formula? Difference in means. It is this one. T is equal to d bar minus mu divided by this. This is standard deviation of d bar. Okay, so this is standard deviation. Okay,
Okay.
so this is all done. Yeah. So remember here, the point is paired comparison or means of dependent sample or means of different differences is equal to this formula. D bar minus mu divided by standard deviation of d bar. Okay, so T is equal to d bar minus mu divided by standard deviation of d bar. Okay. Then next one. This is all fine only. Variance pop. Remember, so far we were checking not variances. We are checking what means. Okay, so this
Yes.
t test is to check means. Okay, so I'll give numbers here. This is third number. Then next one is fourth. Fourth is chi-square test. Now, when do we use chi-square test? When you want to check variance. Now we are jumping from mean to variance.
Yes.
Okay, so when you want to check variances, okay, variances, want to check variance of your sample data set with its own population variance. So variance checking. Okay, then we will use chi-square test. So this represents what? N minus 1 means what? That is sample. This is sample variance. This is population variance. This is okay?
Yes, sir.
Then next one. Mm, Next one is F test, right? So in F test, F test should be used when you want to check, should be used when you want to check variances, when you want to check variances of when you want to check if the variances of when you want to check if the variances of two different populations, two different populations are same or not. So that time we will go for F test. That is equal to variance by variance. This is bigger variance and this is smaller variance. Is okay?
Yes, sir.
The next one. Yeah, so majorly that in between that stuff only I had to cover. So now rest all will be okay. Then, okay, parametric test and non-parametric test. This theory is also needed. So basically, you can say parametrics, this characteristics. See, parametric test relies on assumption regarding the distribution of the population and are specific to population parameters. For example, z-test relies upon a mean and standard deviation to define the normal distribution. The z-test also requires that either the sample is large, relying on the central limit theorem to assure a normal sampling distribution, or the population is normal distribution. You can simply remember that parametric test means test done on normal distributions. Okay, test done on the uh, uh, on the uh, on the data distributed normally. Okay, normally distributed
Okay.
data. When you use that time, it is parametric test. If it is non-normal, rest all will come under non-parametric. Okay,
Okay.
so anything normal distributions all will be parametric. Apart from that, everything is non-parametric. Okay, say for example, here you see either do not consider non-parametric test, either do not consider a particular population parameter or have few assumptions about the population that is sampled. Few assumptions, that means we are not sure about whether it is uh, how it is actually getting distributed. Non-parametric tests are used when there is a concern about quantities other than parameters of a distribution, or when the assumption of parametric test can't be supported. That means it is not normal. They are also used when the data are not suitable for parametric. Ranked observation. Ranked means you are converting data into rank, and then further you are doing some studies. Basically, in short, you are not working on the normal distribution data. In that case, all these will be categorized as what? Non-normal or non-parametric test. Is it okay?
Yes, sir.
Okay, apart from normal distribution data, rest everything is non-normal. Few assumptions, remember this also, few assumptions. This kind of theory only they will ask. Okay. You may just go through this also. So if neither the t-test nor z-test is appropriate, then non-parametric test can be called for. Now, how that is being done, certain one or two tests, are there for us also, that we will see now going ahead. Okay, some non-parametric test also we'll see. Okay, this ranking, fine. Okay, okay. Now this is one non-parametric test. Okay. So what is this non-parametric test? Basically, we are not checking the data directly. We are checking the correlation, okay, of two variables. Just go through this one now. Read the question.
What is correlation coefficient?
That means normal correlation only. Correlation.
Okay.
Correlation is only called as, the complete name is correlation coefficient. So basically, if I say for example, correlation between two variables x and y is 0.35. Okay, so you know that correlation will always be between -1 to +1. +1 is what? Perfectly positively correlated. -1 is perfectly negatively correlated. 0 is no correlation. Now, what do you think? 0.35 is a very, it is highly correlated or not highly correlated?
Sorry, sir.
0.35 is highly correlated or not highly correlated?
Not highly correlated. Right?
Okay, but I'm saying it is highly correlated. So now we have to prove. Correct? So there should be some
Yeah.
mechanism, no? Because now you have a
Right.
different thought, I have a different thought. If it is 0.9, probably we might have the same thought, that we will say it is highly correlated. But if it is 0.35, 0.4, we can have difference of opinion, correct? So
Yes.
we should have some mechanism to prove whether it is highly correlated or not. So how do we prove it? So using this test, it is also called t-test only, but t-test for testing correlation. So that means when we want to check the correlation, okay, when we want to check the correlation of two different variables, when we want to check the correlation of two different variables, so that time r is equal, no, that time t is equal to, okay, so t is equal to r into root of n minus 2 divided by root of 1 minus r square. This is the formula. Now let me derive this. See, t-test normal formula is what? X minus x bar divided by standard error. So standard error means root of standard deviation, no, standard deviation divided by root standard deviation divided by root n. Correct? This is standard error. Fine. Okay.
Yes.
Now this standard deviation also I can write as x minus x bar divided by um, root of summation of x minus x bar the whole square divided by n minus 1, then divided by root of n. So here uh, now acha, so this actually the form, this formula is in this form, r minus 0, because I'm checking if this r is you know is equivalent to 0 or not. Equivalent to 0 means what? No correlation. Otherwise
Yes.
correlation is there. So the actual formula is like this. This is like this: x minus x bar divided by standard deviation is, see, this r square means correlated. Okay, you will come to know this in the next chapter better. Basically, r square means what? Say for example, r in this case is what? 0.35, correct? So what will be r square?
Yes.
Just check
Yeah.
r square.
0.1225.
So 12.25 percentage. So what it means, that means 12.25 percentage of y is uh, okay. Uh, okay. 12.25 percentage of y. 12.25 percentage of y is explained by x. This is what it means. 12.25 percentage of y is explained by x. You understood what I said now?
No, sir.
12.25 percentage of y, that means y is variable. Whatever y, whatever y's output is coming out of that, 12.25 is because of x. For example, uh, whatever you are studying, 20 percentage is because of your friend, because your friend is forcing you to study, or your friend is also studying, so you are also getting influence and you are studying. So 20 percentage of marks is because of your friend, 80 percentage is because of your own effort.
Okay.
Okay, like for example, uh, because Nifty is going up, stock is also, a particular stock is going up. We will see this in detail in the next chapter. Next chapter is all about this one only. So right now you just think that this is similar to correlation. So 1 minus that correlation is what? Deviation. So this is standard deviation. Okay, 1 minus r square is, you think it is correlated, so 1 minus will be not correlated, no? Not correlated, divided by that root n. Only I'm writing as root n minus 2 because there are two variables over here. So degree of freedom here, it is n minus 2.
Okay.
So this is the original formula, which I will shift. So this, because this 0 I'm ignoring it, I will shift it over here, r into root of n minus 2 divided by root of 1 minus r square. Have you understood this formula now?
Yes, sir.
Okay, rest is just plugging in the number. Now you go through this sum, you should be able to, you should be able to understand. This is just one step, and then you read this theory as well in this part. Read now.
Done, sir.
Hmm. You understood this one now? Okay.
Yes,
This
sir.
is one example of what non-parametric, no? Because we are not checking any normal distribution data. We are checking correlation of that data. Okay.
Okay.
Then next one, so seventh one is Spearman's rank correlation test. So this is another correlation, Spearman. Spearman's rank correlation. Have you ever heard about this one, Spearman's rank correlation? Rank. Basically, here we are checking if the ranking of two variables are same or not. Say, for example, let's say this is fund X and this is fund Y. Okay, two mutual funds are there. Mutual fund X and mutual fund Y. So mutual fund X's returns are like 15, 18, 17, 10. Here this return is 16, 13, 15, 12. So now I'll give rank. So this is the question. Okay. Now rank for fund X. So I'll give rank this one first rank. This should be second rank. This should be third rank. This should be fourth rank. Then rank Y. This is first rank, second rank, third rank, fourth rank. Okay, this is the rank. Now, now we want to see if these ranks can be used to test whether two sets of ranks are correlated. So these ranks are correlated or not. So again, in the same way, I'm going to find the difference between ranks. D stands for difference between ranks. So difference is what in this case 2. In this case also 2. Okay, it is not -2. Just the difference 0, 0. So what is the difference? 4. So this is 4, and the formula here is R is equal to 1 minus 6 into, so 6 is a part of the formula. Okay, so when we try to derive this formula so that time 6 comes in that. So I'm not getting into the derivation, but it is a part of the formula. 6 into d square, summation of d square. So this is the summation of d. So d summation of d, so d square will be for 16, correct? So it will become 16 divided by n is 4, right? 1 2 3 4. 4 square minus 1. Just calculate this now. So 1 minus, you calculate this number.
So can you show the um, 60?
1 minus 60, 60.
60% final answer.
Okay, final answer is 60%. That means 0.6.
Yes.
R is 0.6. Now you have to do the same testing, that T is equal to R into root of 1 n minus 2 divided by root of 1 minus r square. So now you calculate all this now.
So you're taking NH4, right?
Huh. Yes.
Is it 3?
No, I'm not doing it. Okay, you got 3. Okay, should I do then 0.6 into root of 4 minus 2 divided by root of 1 minus 0.6 square? Okay, I'll do them. Right. So 2 to 0.6. The numerator is right. Then square 0.80. 1 point, I'm getting 1.06. Have you got this number?
1 second, sir. Yes, sir.
Correct, no?
Yeah.
And then we'll see here minus 2 plus 2. So minus 2 plus 2 means what? No change. That means no change in the correlation. So here null will be it's a non-parametric test. Okay, see, this is a non-parametric. Okay, can be used to set shared. Okay. Friends are so here null will be no change. That means, so no change means null is supposed to be correlated, equal to no change. General belief will be not correlated. Just check once. Okay, wait. Correct only. So no correlation, not correlated. And alternative is correlated. So here we will accept this one because it is falling within the range. So it is not correlated. Yeah. Is it okay now?
Yes, sir.
Okay. Then this is, they may ask you this kind of question also. N minus 2 is the degree of freedom, okay, for Spearman's rank correlation. Finally, it's a correlation, no? So that time we take two variables included. Think like that. Fine, okay.
Okay.
Then next one. So I think all complicated stuffs are all done, but few more tests are pending. Next one is to test independence of uh, test of independence based on contingency table. Now next one. Now this is seventh one, so eighth one now. Test of independence based on contingency table. Test of independence based on contingency table. Now, what do you mean by this contingency table? Contingency table means this is contingency table where you have data row wise as well as column wise. Okay, so row wise as well as column wise. This is earnings growth, and dividend yield, low, medium, high total. Okay, so 28. So these are the numbers 28, 42. So basically, what it means, 28 times when the dividend yield was low, earning growth was also low.
Okay.
Understood the meaning? 28 times both dividend yield and earning growth, they were low. Okay. 53 times dividend yield was medium, but earning growth was low. 42 times dividend yield was high and earning growth was low. Is it okay?
Yes.
Okay. 42 times dividend yield was low and earning growth was medium. Then 32. This is how you have to understand this data. Okay, so this is the total. So this is row wise total and this is column wise total. Both the sides, if you add, it will come to 324.
Okay.
Okay. So now, uh, mhm. So now we want to know whether they are dependent or not. Okay, whether they are dependent or not. This is the question. Okay, so how do I do? Uh, okay, so null will be what? Both are not dependent. Null, no? Not dependent. Okay, till here question is okay.
Yes.
Null decision rule. Null will be both are not dependent. Both means earning yield and dividend yield. Both are not dependent, equal to 0. Not dependent. Alternative is not equal to 0. Both are dependent. Okay. So now how to do this? So when you want to check the independence of data for contingency table, okay, we should use chi-square test. Now here the formula changes. Chi-square is equal to summation of observed data minus expected data. Observed value, expected value, or data use or value you say, anything is okay, divided by expected data. And this is the summary. Okay. So how do we do this now? It's a simple one only. It's lengthy but simple one. So first of all, I have the observed data. This is what is given to me, observed. Now I have to make expected data. So how will I create expected data now? So again, same way, earnings growth, earnings growth and dividend yield. So low, medium, and high, right? Low, medium, and high total. Low, medium, high. Okay. So this low will be, all you have to do is, instead of 25, my for the observed value 25, my expected value will be 119, that columns total into rows total divided by overall total. So columns is 119 into 112 sorry, not 112, 123 divided by 324. Just calculate this.
45.175.
45.17. Okay.
Yes.
Okay, fine. Now second one is, again, second one, 119 into 113. 119 into 113 divided by 324.
41.503.
41.50. Okay. So then 49 in, not 49, this is 119. Na? 119 into 88 divided by 324.
32.32.
32.32. So this is how you are supposed to get the expected value. 32.32. Now here second one is 110 into 123 divided by 324.
0.040
Hmm?
minus
Hmm?
minus point
How
zero four
minus?
zero.
There is no minus na, here.
Oh, sorry, sorry.
110
110
into 123 divided by 324.
41.75.
Okay, then next one medium, 110 into 113 divided by 324.
38.36.
38.36. Then next one, 110 into 88 divided by 324.
29.87.
29.87. The next one, high, this one, 95 into 123. 95, 123 divided by 324.
36.04.
36.04.
04.
Then 95 into 113. 95 into 113 divided by 324. Now,
33.132.
okay. Then next one, 95 into 88 divided by 324.
25.80.
This is not required. Okay, these all we have got observed number. It is very lengthy. I don't think again this lengthy sum they will ask you, but something in this sum might be asked. Okay. Now I just have to just plug in the number only. See, the formula is observed minus expected. This is numerator will be squared divided by expected. This is the formula. This is squared divided by expected and then totaled. Okay, so that means observed, first number is observed is what? 28. Okay, so 28 minus 45, this one,
Yes.
0.17 squared divided by 45.17. Just calculate this and keep it in store one.
6.52.
Okay. Then next one, 42. 42 minus second one is 41.50 divided by 41.50. Huh.
0.6024.
Hmm? Hmm?
0.6024.
Keep storing, okay? The
Yes.
next one is 49. 49 minus 32.32 square divided by 32.32.
8.60.
8.60. Okay. The next one is 53. So 53 minus 41.75 square divided by 41.75.
3.03.
The next one is 32 minus 38.36. 38.36 divided by 38.36.
1.054.
1.054.
Yes.
Okay. 32, 25 then. 25 minus, so this is last one, 25, 29.87. Hmm.
0.794.
0.5, huh? How much? 0.794.
7. Yeah.
Okay. Next one, 42 minus 42, 39, 14. Okay, 42 minus 36.04. Huh.
0.985.
You're storing all right.
Yes.
To 39 minus 33.13.
1.040.
Last one is 25.80. 25.80.
5.39.
5.39. Okay, summation of all, add up all this.
$28.03.
Yeah. So 27 they have got, which is okay. This is one, this is all decimal, one difference. We can roughly check 6.52 square differences, 54, so which is okay. 8.6 is okay, fine, this much is okay. Okay, so now what will I do? I will go to chi-square table. Okay, so chi-square table. So chi-square table will be like this, right? And here degree of freedom will be n minus 1 for the first earning growth into n minus 1 for dividend yield. So that means 4 minus, not 4, uh, no, in this case 1, 2, 3. Okay, 1, 2, 3. So 3 minus 1 into 3 minus 1. So 2 into 2, 4 degree of freedom. So we'll go to the last page. So here degree of freedom is 4. So fourth row. Okay. And here first one is this part, total 97.5. This one, fourth row, 0.484. Normally left hand side, if you ignore also, it doesn't matter because it will be in this point only, so it doesn't matter. Right hand side is more important, so which is 22.5 will come here, fourth row, 11.143. Okay, 11.143. Okay, so now this answer is 28, no? So 28 is falling outside this, right here.
Yes,
28. Okay, so that means we will reject the null. That means what? They both are dependent. Understood this one?
Yes.
This is chi-square to check the independence of data. All these are what? Non-parametric test only, okay?
Okay.
Fine, this is understood, right? This is okay. See, what they have done is, they have done, for them, they got 9.488. How 9.488? We got 11. So 9.488 they have got. That is because I think they must have directly checked 5 percentage. We checked 5, we checked, this part here 97.5 and then here 2.5. No? I think they must have checked directly 5, which is okay. Anything is okay. And in the exam, anyways, only one table will be given to you. 9.488, right? This one. Yeah,
Yes.
they directly they ignored this completely and directly checked right hand side 5%. But you will not get any borderline question and all those things. Okay. See, what we have done is correct only, but practically, because as I said, left hand side is ignored normally because it is just 0 point. So they just make it a right side one tail table kind of thing. Okay. So if you want to follow that also, you may follow. Anything is okay. Hmm. I think this is it, na? That's it. Okay. Then next one is linear regression that we can do next time then. Okay. So this also requires fresh mind. It will a big lengthy sum I will be doing. And then one more session I will do to explain the theory part of it. So 2 sessions and then this will be done. And after that, one small theoretical topic is there that will be over soon. Okay, in few minutes. So in 2 to 3 sessions, this will be over. Okay, and then we can do with uh, FSA then.
FSC.
All right. Okay.
So tomorrow, can we connect in the morning if it's possible?
Yeah.